How could math help you any more than with your finances? That's what we're going to be talking about for the next couple of weeks. Let's look at the basics first. Interest. This is free money that you can get. Remember what interest is? And we're going to start with simple interest. Simple interest is an amount that you get, that you accrue, in an interest-bearing account over time for a single deposit. In other words, your grandmother gave you $100 once and you put it in the bank. Not a bunch of payments, just one single deposit. We'll start with that now. And you get interest compounding once a year. Hence the term simple. A single deposit, once a year's worth of interest. Now, we're going to have a formula for simple interest. It's P times R times T. P is the original amount that you put in, the principal we call it. Okay? R is the rate of interest, which is usually some percentage, so get used to that being a decimal. And of course T is the time that you invest this money, the time that you let the bank hold it. And that's usually going to be in years.
Allow me to demonstrate.
Okay, let's look at a typical problem. We want to know the interest that we would make on $2,000 for 1 year at the rate of 7% simple interest. Now, they said simple interest in this problem, so that's just per year. So we're going to take the principal, 2,000, multiply by 7%, and multiply by the time, in this case 1 year. Now that 7% is a decimal, 0.07, 7/100ths, remember. We do the calculation, and we get $140. Now that's interest.
It's mine, you understand? Mine, all mine.
Of course, you get your original 2,000 back also, so you really end up with 2,000 and 140. So we're going to come up with a new word here, how much we've accrued after 1 year for 2,000 at 7% simple interest. Similar problem, but we don't want to account for just the interest. We want our principal and our interest, because that's how much money you get back. So we have a new formula. We have our original amount, 2,000, plus 2,000 times the interest rate. So hopefully you can see how I come up with a formula here of 2,000. I don't want to write 2,000 twice. It's going to be 2,000 times 1, the original amount, plus the interest rate. So you're going to be seeing this 1 throughout the whole rest of the class because you get your original money back. Well, you're going to see 1.0 whatever the interest rate is. Okay, so get used to seeing that 1 because you get your original money back. And that, of course, would be the amount you would get.
Are you pondering what I'm pondering?
Well, what if we keep it in there longer? We're starting to make a little bit of money. How much would we accrue after 2 years for the same amount of money, $2,000? We're not putting any more in. We're just going to start with $2,000 at same interest rate, 7%. Well, we're going to get the first year, we're going to get our $2,000 times 1.07. Then we're going to take that amount after 1 year, and we get another 7% on that. So I'm going to multiply that by 1 because I get the original amount back, and 0.07. So that's what we get for the second year. Get a little bit more money, don't we? $2,289.80. Well, let's see if we can come up with some sort of a pattern here.
Show me the money!
What would be accrued after 3 years? Let's look at it. Well, we'll have our 2,000 times 1.07. Of course, that's the first year. And then we'd multiply times 1.07 for the second year. And then what are we going to do for the third year? Of course, we're going to multiply by 1.07 for the third year.
Excellent.
Get even more money, right?
Pay attention, son. Look at me when I'm talking.
Well, so our general formula to calculate amount accrued with using just simple interest is going to be A being accrued That's how much you get at the end. P being principal, R being rate of interest, and T being the time in years that you invested it, is, I hope you appreciate, principal times 1 plus the interest rate to the T. We're going to multiply by 1 plus the interest rate times itself that many years, as you saw in the last example. That's the key.
It's not the principle of the thing, it's the money.
Let's try and use this formula for a different problem, because we usually don't keep money for 1 or 2 years. You keep it for 5, maybe 10 when you invest money, until your children get to college or something like that. So it may be for a long period of time. This formula is going to become much more useful. Well, in this case, we're going to invest $500 at a rate of 4.5%, and we're going to see how much we have after 5 years. So we'll multiply 500 times 1 plus, remember what 4.5% is, 0.045, and then we'll multiply that portion to the 5th power. Well, this is a job for your calculator, and let's do that. Go ahead and take the time, multiply 500 times, make sure you use your parentheses, 1 plus 0.045 and parentheses, use your to the button, to the 5th, and I'm hoping you get, wow, $623. That's basically $123.09 of free money, isn't it, over 5 years. Now, that's simple interest. That's if they compound the interest 1 time a year. But you know what? Banks really compound more often. That's good news for you. They more often than once a year, don't they? Of course, if we put in, let's put an easy number, $1,000 at 8% simple interest, that's compounding once a year, we'd get, as we remember, our original amount, $1,000 plus 1,000 times the 8%, or 1,000 times 1 plus 8%. Get the idea? And we get 1,080. That's simple interest. That's compounding once a year.
How about a little fire, Scarecrow?
What if we compounded twice a year? I hope you expect you're going to get more money. Well, let's see. How much are we going to have after 6 months? Well, I'm going to have my original amount, 1,000, plus 1,000 times, you don't get the full 8%, you get half of that, don't you? Because it's only been 6 months. So, or we could say 1,000 times 1 plus half of 8%.
Is that your final answer?
Well, wait a minute. We want to do it for the whole year. So after 12 months, and that'll be after 6 months, after 12 months, we'll take that amount, same amount, and then we have to multiply it again by 1 plus the interest rate divided by 2. Why divided by 2? Because we compounded twice a year. Well, guess that's $1,081.60. It's not that much more, but it is more. It's about $1.60 more, just compounding twice a year as opposed to once a year, which is simple interest.
Now you listen to me. I want details, and I want them right now.
Okay, we're not going to belabor this. We're going to get right to the formula for multiple compounding. Sometimes, certainly, they compound more than twice a year. They compound 4 times a year, maybe once a month. That's often. That would be 12 times a year, of course. So,
It's mine, you understand? Mine.
the formula for multiple compounding of the accrued amount is going to be principal times 1 plus your interest rate divided by that M we're going to put in there. And M is the number of periods or number of times per year that it gets compounded. In the last problem it was 2, wasn't it? And we're going to take that and we're going to raise it to the MT power. And last time it was to the 2T power, right? Because M was 2. So you're going to actually use that M twice.
Now what am I gonna do?
Let's try one. How much would an investor accrue if they took $500 at an interest rate of 7% for 4 years, and the interest is compounded monthly. Okay, monthly means, of course, 12 times a year. Well, let's put in all the magic numbers, and you see where you get your 500 for principal, 7% for interest rate, the 12 is the monthly, and T is 4 years in this case. Okay, we'll use your calculator.
Now I use my secret weapon.
But I gotta warn you, this is what we're going to put in. Note the orange parentheses.
Oh, it didn't work.
If you don't put those parentheses there, it won't work. It's critical that you put parentheses around any exponent, because the order of operations, if you didn't put them, would have it raise all this to the 12th power, get an answer, and then multiply the answer by 4. That's not what we want. We want to raise everything to the what? To the 48th power, to the 12th times 4th power. So we need it to do that first. So any exponent, make sure you put parentheses around it.
Woohoo! Come to Papa.
And look what we get here. The answer should be $661.03, approximately.
Do that again.
Let's do another one. How much would an investor accrue investing $3,000, this is a one-shot deal, at an interest rate of 10% for 5 years, when this time we're going to be compounded quarterly? That's another common one. Things are compounded quarterly. Of course, the magic number there is 4. We put all our magic numbers in. 3,000 for the principal, 0.10 for the interest rate, and 4 for the M, and 5 for the time. Get out your calculator. Get busy. And you should type in, don't forget your parentheses.
Warning, warning, warning.
Always put parentheses around an exponent if there's some calculation to be done. And the answer you should get is $4,915.85. Not too shabby for free money.
Now, I want these financial calculations to be as useful to you as possible. And probably the most powerful tool that you could use would be a spreadsheet. So we're going to use that, and I'm going to go over how to use a spreadsheet in a way that will work hopefully for any spreadsheet. We're going to use Microsoft Excel, but the way I'm going to show it to you is going to work pretty much for any spreadsheet that you choose. Okay? Now, any spreadsheet, when you go to type something into a cell, for instance, right now I'm sitting in cell C5. If I want to type something in, really important concept is whether I'm going to type it in as a value, and it will be calculated, or as a label. Now, if you're going to do stuff with something other than numbers, then you don't need a spreadsheet. Most of what you're doing in a spreadsheet is values and calculations. That's why we don't say numbers and text. The only reason you would use text, as you can see, for instance, up in the column headings, would be to label values, okay? Or over here, the row heading, to label what row we're talking about. Everything else, and most of this, should be numbers, values, answers to calculations kind of a thing. Now, what's going to decide whether you type something in as a value or a label is going to be the first character that you hit. For instance, I'll type the value 26. The first character that I hit was a 2, and when I hit enter, I'll know that it's a value. One reason is that the default alignment for a value is the right alignment. Do you see that that's aligned to the right, whereas the text over here is aligned to the left? That's the default. Now we can change that. As you can see, I changed it for the column headings to make things line up nice. But the default alignment for a value is right, and the default value for a label is left. And that'll work in any spreadsheet. Okay, let me put another value in for weight. We'll say I'll just make up anything. And I'll hit enter. It's not in there until I hit enter. Okay, now if I'm going to put in a label, let's put in a label, person's name John. When I hit enter, the first character that I hit was a J. Now, let's review. If you hit a number, the plus sign, the minus sign, or the equal sign, the spreadsheet will treat it as a value. If you begin with anything else, it's going to treat it as a label and not calculate it, kind of a thing. Okay, so the first character I hit there was J for John, and as I hit enter, I can see that it did treat it as a label because it's left aligned. Now let me go a little bit further in this idea. Suppose I wanted to add those two ages. The ages are sitting, as you can see, in cell C4 and cell C5. Well, I'm going to put the sum of them here. Now, if I stupidly, don't say anything, said I want C4 plus C5, if I type C4 plus C5 and hit enter, what is it going to treat this as? It's going to treat it, what was the first character I hit? Was a C. So it's not a number, plus sign, minus sign, or equal sign. So it's going to treat it as a label, and it's not going to calculate it. It's going to treat it as a label. I'll hit enter and simply display it. Of course, that wasn't what I wanted, was it? If I really want to calculate that and have it treated as a value, I must begin with one of those. And of course, the common thing to do is to use the equal sign. Let's do the same thing, except begin with equal C4 plus C5. Now, when I hit enter, look, it's trying to help me by color coding things. When I hit enter, we won't see C4 plus C5 like we did before. We'll see the result of what the sum of those two things are, the sum of those two cells are. Pretty cool. The important thing here is that I need you to know the difference between the spreadsheet treating a cell as a value and calculating it and displaying the result, or as a label and just displaying the exact text that you typed. Now, one of the reasons that you want to keep in mind always the difference between whether something's stored as a value or a label is that there's something you can do with a value that you can't do with a label, and that is you can format it. You can have it show the way you want it to show. Let me give you some examples. This area here is all values, numbers if you would, and of course there's your labels labeling those values. Let's take this cell, just this cell, and format it. Since it's principal, I would probably like it to show like money, currency. So what I'm going to do, I selected it with the left cursor. Then I'm going to do what's called inspect it. Inspecting is hitting something with the right cursor. Now I've already selected it with the left, and I'm going to inspect it with the right mouse button. If I hit that, what will happen is the spreadsheet will bring up a list of items or options that I can do to that object. This works for any object, by the way, in Microsoft. That way you don't have to go looking through the menu or looking for buttons that may or may not be there. This will work for any type of spreadsheet. So I right-clicked. Now I'm going to go back and select. You see, I'm selecting. So if I'm selecting, I'm going to hit the left button. And I chose to select format this cell. And it brings up the list of possible formats that I can do. I see. I can select number, currency, accounting, very, very many. Probably the most common one we'll use, one of them, is currency, and you can tell how many decimal places you want it to show, for instance. I'm going to leave it like that, currency with 2 decimal places, and select OK. Once again, notice I said select, so I'm going to be using the left mouse button. I'm pretty much going to use that every time, except when I inspect. And son of a gun, you see how it looks like currency with 2 decimal places. Now, perhaps it looks different. It's stored the same thing. Both of them store 120,000. This one just happens to show it fancily, if you would, as currency. Let's show this one as currency, but have no decimal places, for instance. Okay, I selected it. I'm going to right-click to inspect, come down, and I'll select, and I'm going to go back to the left again now. So basically it's left, right, left, okay? And I'll select Format Cells, and I'll select Currency. And this time I don't want any decimal places. I'm not going to worry about cents. And I'll say OK. And son of a gun, it looks like that. Note up here that I'm still only storing 230,000. I'm showing it fancily as currency with no decimal places. Now, a lot of times, interest rate, for instance, you want to show as percent. That's another one of the formats. So let's select this cell, right-click to inspect, and come down, and I'm back to the left clicker, Format Cells, and I'll pick percentage. Okay, this time we'll say percentage with 2 decimal places. Say OK. And pretty cool, I have 9%. Now, if I wanted to show it with only 1 decimal place, I can still do that. I'll right-click, select, go a little faster now. It's already on percentage. It's telling me the way it is now. And I'll say, I'll tell you what, let's show it with only 1 decimal place. And say OK. And as you can see, it has 1 decimal place. Okay, let's try one more time with this cell. Now, do you recall what will that look like as a percent? 0.065. Remember, the hundredth spot is the percentage, so it's going to be 6 and something, 6.5%. Let's inspect it with the right clicker, select Format Cells, and this time I want percentage. And I don't know, how many decimal places do we want to show? We'll show 2 and say OK. And pretty cool, you get 6.5%. Note, what was stored there is 0.065, but it's showing maybe a little clearer to the user what is going on. So that's the idea of formatting, and I'm going to expect you to know how to do that. Now let's get to the power of this spreadsheet, the ability to do advanced calculations. Okay, we learned about that interest is principal times rate times term. Well, let's use the spreadsheet to calculate that. In this case, it's 123,000 times 6.5% times 30. Well, I would have to begin with an equal sign, of course. And I could do 123,000. And now I'm going to use the operators over in the pink box. Multiplication uses the asterisk times 6.5% or 0.065 times 30 years. I'll just type the 30. And once I hit enter, pretty cool, it'll give me that calculation. And even better, I'd like you to notice this is the result of that formula, but up here you can see how you calculated that formula, just in case you made an error. That's called the edit line. So if you wanted to change it, you could click here and change it to 32 or whatever you wanted to do, kind of a thing. Okay? But probably the better way to do this, I'm going to click here and hit delete, is reference these cells, and I'll show you why in a minute. I'm going to delete this, and instead of actually typing the numbers, I'm going to again begin with the equal sign, and I'm going to reference this cell right here, the 123,000. That's cell B3. Now I could type B3, but I might screw it up. So what I'm going to do is do what's called pointing. I began with the equals, and I'm going to point and click to it, and look how cool that is. The spreadsheet automatically typed B3 for me. Now I'm visually checking it, so I know I didn't screw up. That's why I want you to use this point referencing idea. Okay, now I'll hit the times again, and I want to multiply it by cell B4. So I'll point to that and click, and son of a gun, do you see that it put it in there? It even color-coded it. All spreadsheets do that now. Times cell B5. I'll click on that, and it puts it in there. Now all I have to do is hit enter, and I can see the result. And if I click on it, I can see what I didn't really type it in. It typed it in for me as I pointed and clicked. The power of referencing those cells now is if I change the number, because this result is based on the contents of these cells, not those hard numbers, unchangeable numbers, if you would. If I change this, for instance, to 300,000, as soon as I hit enter, hopefully you'll see the interest changed, didn't it? Okay, so as I type various numbers in, I can type another number in, this is going to change. Pretty cool. Maybe the interest rate would change to 7%. Okay, and that's going to change. Okay, let's do it again for this one. Okay, remember that interest, we learned earlier in the class, is principal times rate times term. That's simple interest. So I'll begin with the equals, and I'll use my point and click. This cell, I don't even need to know what cell it is. I just point and click to it, visually checking it. Times this cell right here, click, times this cell right here, click. Apparently it's D3, D4, and D5. And I'll hit enter, and son of a gun, I'm starting to get I got the answer, but a very powerful way that I got the answer, because now I can go up here and change any of those numbers, and I'll still get yet another answer, you see. I wonder if you've noticed that we're accelerating a little bit here, aren't we? We're getting a little bit more complicated, but I think it's going to be way easier and more powerful if you use this point referencing idea, and we're going to be able to use all the formulas that we learned in this class. Now, so far we've done simple interest. Let's try doing compounded interest using the same numbers. In this example, let's look at what we've accrued if we compound this situation monthly, 12 times a year, for 30 years. Of course, we're putting in a calculation, so we must begin with the equal sign, and it'll be our principal, but I'm not going to type 123, you see. I'm going to point to it. And then we'll multiply by, and remember the formula in parentheses, 1 plus interest rate. I'll point to that. Now this is monthly, so we'll divide it by 12. And then we raise that. There's the exponent. Raise that to, and remember that all exponents must be in parentheses. Raise that to the power of 12 times the term, and the term is stored in this cell right here. And there's your formula. B3 times 1 plus B4 divided by 12 to the 12 times B plus 5. And let's see what we end up with. Now we can format that. We'll do that a little bit later, but let's look at what we have. Okay, that's about 859,000. Now let's do the same thing compounded quarterly with the same numbers. Okay, again, I'll begin with equals. I'm going to use these ones up here. Point to the principal. Use my multiplication. 1 plus interest rate. I point to it. Now this is quarterly. So we're going to divide by 4 and raise that. Remember, exponents always go in parentheses, to the 4 times the term, which is 30. And you can see your formula, and I'll hit enter. Pretty cool if I sit on this, by the way. I can see the formula up here, see actually where I got my calculation. I see the numbers are different. I have a little bit more money when it's compounded more often in monthly. Now let's review lastly and format this. I can format both at the same time. I'll select both of them by dragging and right click to inspect. I'll select format cells. I'll select currency. Now this amount of money, I'm really not worried about cents, so I'm not going to show the cents. I'll change to 0 decimal places and say OK. And pretty cool, you can see that the more often you compound, the more money you get, of course. Okay? Well, I think that's certainly enough for today. let's go practice this with your homework and use your spreadsheet, because your homework will go very quickly. I want you to get good at this if you can. Okay, because we have more spreadsheet work and more financial functions coming up.